As competitors evolve and older aircraft age, the fifth-generation F-35 is crucial to retaining air superiority today and in the future. The combination of very low observable stealth, sophisticated sensors, information fusion, and network connection defines fifth-generation capabilities, all wrapped into a supersonic, long-range, highly maneuverable fighter. With its sophisticated technology, the F-35 is a multi-role fighter capable of performing any mission, including novel missions not normally performed by older aircraft. Whereas fourth-generation fighters are compelled to adapt to this evolving battle space, the F-35 alters the power balance and may define the battle space that U.S. opponents must adapt to. The F-35's capacity to acquire, analyze, and exchange data is a strong force multiplier that improves all aerial, surface, and ground-based assets in the battle space. Now, in this video, we will concentrate on the F-35's extraordinary physical capabilities. Keep an eye out. First to be noticed in the vehicle is its ability to take off vertically. In actuality, the F-35 family includes three variants, all single-seat jets. The F-35A with conventional takeoff and landing variant, the F-35B, the short takeoff vertical variant, and the F-35C carrier variant. While the F-35A and C are the more common variants and were designed to operate from conventional runways, the F-35B can land vertically like a helicopter and take off in very short distances. This allows it to operate from austere, short field bases and a range of air-capable ships. With more than 40,000 pounds of thrust according to the manufacturer, the F-35 in air can be propelled to maximum speeds of about Mach 1.6, i.e. 1,200 miles per hour, or about 2,000 kilometers per hour. All variants of the F-35 fighter jets are powered by the Pratt & Whitney F-135, an engine developed specifically for the program. Unlike the F-22, the F-35 does not have in-flight thrust vectoring, in which jet nozzles can swivel and help the carrier turn faster. And admittedly, other older aircraft are faster. For instance, both the F-16 and F-15 can both exceed Mach 2, or twice the speed of sound, according to the Federation of American Scientists. But the F-35 has control surfaces, its tail's vertical and horizontal stabilizers, that are larger than some small aircraft's wings. That and advanced flight computers allow the plane to maneuver at speeds in which other planes would simply fall out of the air, according to Lockheed Martin. Moreover, the plane is designed to be fast, but not the fastest, nimble, but not the most nimble. The manufacturers declare that its main advantages include being nearly impossible to track with radar, and that they are packed with advanced sensors and other gear. The true capacity of the vessel's ability to evade enemy radar, however, is not public. Its radar cross-section, the size it appears on a radar scope, is a heavily guarded secret. Alongside that is a sensor system designed to vacuum up information about the airspace around the F-35 without giving up its position. Tiny cameras mounted around the plane can project a real-time 360-degree picture of the world for night operations, or so the manufacturer says. The jet has not been without its fair share of justifiable critiques, the biggest of which centered on the sheer cost of its production and operation. In 2012, the Pentagon estimated the lifetime cost for the F-35 at more than $1.5 trillion over 50 years, by far the most expensive aircraft program in U.S. history. Fortunately, crashes or unsafe operating characteristics have not been among the aircraft's problems. Following the crash of 2018 in South Carolina, linked to faulty fuel tubes in the engine, there has only been one other account of wreckage of the fifth-generation vehicle, when the military jet crashed while taking off from the aircraft carrier last month, but has now been recovered in the Mediterranean. Information concerning this crash was put under serious hush-hush, as the salvage operation was secretly done by British, Italian, and American crews to prevent the aircraft and its sophisticated radar and sensors from falling into hostile hands. That we even know of this crash is due to leaked video footage that appeared on Twitter soon after the incident, after someone held up a phone to a computer screen to copy a CCTV recording from the HMS Queen Queen Elizabeth's control tower. The sailor responsible for the 16-second video clip of the F-35 crash was soon after arrested, but the video had already gone viral over social media. It's not exactly clear what caused the crash, but one theory put forward is that something, possibly a plastic rain cover, may have been sucked into the aircraft's engine, prompting it to fail. However, this is just speculation. Over the years, stealth technology has expanded exponentially, culminating in the unprecedented capabilities of the F-35 Joint Strike Fighter. With an easily maintainable 5th-generation stealth design, advanced situational awareness, and highly integrated mission systems, the F-35 Lightning II is highly survivable and lethal as deployed in today's advanced air defense threat environments. This plane is designed for total mission success, with the most survivable yet lethal cockpit environment to date. The F-35 combines unparalleled stealth with 360-degree situational awareness and the ability to conduct attacks electronically, along with sophisticated data capturing and a robust communication suite. Poitras, Director of Survivability at Lockheed Martin's Skunk Works division, expects tighter integration with airframe and mission systems designs to balance stealth with other aircraft systems and performance attributes, making the whole greater than the sum of its parts. The next step in stealth advancement will be to focus on cost-effective, high-performing, and reduced maintenance technologies, which will result in lowered ownership costs. Regarding the booming sound after the supersonic jet breaks the sound barrier, Poitras says, "By the time the enemy can hear you, it would be too late for them to react. Sound energy will never arrive sooner than radar energy from the same source and is not useful to announce the approach of a modern fighter aircraft. Indeed, stealth does not provide it with full invisibility, but allows it to elude or greatly complicate an enemy's ability to find and destroy the jet. The plane's shape itself is designed to deflect radar energy away from the source like a slanted mirror. Its surface is also blended and smoothed to enable radar energy to smoothly flow across it. Other aircraft features that are difficult to reshape or treat with radar-absorbing materials, such as the engine compressor face, are hidden from direct view by the threat radars. The plane's conventional probes and vanes are also housed internally to promote stealth. Upgrades in missile technology over the past several years have unfortunately made the F-35 less survivable than previously hoped. Senate representatives note that the F-35 remains more survivable than other fighters by quite a bit, but it's also got some environments that it's not going to be able to get into because of how much missile technology has improved since the initial production of the aircraft. These criticisms can be dismissed though, as rather than point out particular limitations of the vessel, it emphasizes the cost incurred in the craft's lifetime. And now, onto the armory on this jet. Surely the world's most advanced fighter jet needs the most advanced weapons. Raytheon Technologies, responsible for arming this jet and most other military equipment of the United States, is providing precision munitions for firepower. It is a system that delivers real-time information from 6 cameras to the pilot's helmet, as well as an advanced landing system for the F-35 Joint Strike Fighter. The weapons from this company that are aboard the F-35 include the AIM-9X Sidewinder missiles, the first short-range air-to-air missile, up to 2 on its wings, and 4 AIM-120 AMRAAM air-to-air missiles internally, the Joint Strike Missile JSM for offensive anti-surface warfare applications, the JSOW glide weapon, the Paveway dual-mode bomb, the Stormbreaker smart weapon, 8 internally and 8 externally, among other types of sensors and technologies. Other technologies include the Next Generation Distributed Aperture System, DAS, to collect and send real-time, high-resolution imagery to a pilot's helmet from 6 infrared cameras mounted around the aircraft. The company's Joint Precision Approach Landing System, JPALS, will support landings in rugged terrain or poor visibility. The system is secure and can operate despite spoofing or jamming that aims to disrupt its ability to receive valid data or any data at all. All of these features were attached to the F-35 Joint Strike Fighter not to afford it air dominance over its adversaries even in the enemy war zone. Air dominance to the warfighter is the ability to execute the mission, where all the participants of the mission are all protected from anything the enemy would do, whether it be an airplane attacking the force or a missile or some kind of cyber attack. With this line of fighter jets, it truly appears to be that the United States would be able to achieve air dominance in any conflict situation. Let us know what you think about the capabilities of these 5th generation aircraft in the comments section below.